this is chapter 23. Starting from this chapter, we'll be talking about some machining process, and this is the first type of machining process we are going to discuss. It's about, this chapter is all about turning and some other hole making operations. And with these operations, we can produce some round shapes. So we can say that this chapter is all about round shapes. And it's actually one of the fundamental machining processes. And with the help of these processes, turning and other hole making processes, we can produce very small products, or we can produce large products like turbine shafts or other kind of rolling mills. And among these operations, as the name of the chapter implies, actually, we'll be mostly spending time discussing turning operations. And as the name implies, in turning operations, we have the workpiece rotating all the time. So we will try to mount our workpiece to somewhere, then it will be rotating at very high speeds. And then while it's being rotating, we will try to remove material from some surfaces of this workpiece. And the type of machines we use for turning operations are called as lathes, and they are one of the first type of machines we used in the history, and they are highly versatile, which means that you can do many operations on these lathes, on these machines, and these are some examples. For instance, we can do turning, facing, and I will in a moment talk about these, but let's look at here. We can do cutting with our special form tools. We can do boring, drilling. We will discuss these in the upcoming sections. We can do parting, which is simply cutting off. We can do threading, so that we will be obtaining some threads like screws, some external and internal threads. And lastly, we can do knurling. Now, I will focus on this figure and try to explain you all these processes which can be done on the lathe machine. And you will see that there is one specific at the end of this table. I will start from this one actually. This is called as knurling, and it's totally different from the previous ones, previous operations which can be performed on the same lathe machine. This is totally different. This is actually not a machining operation, it's a forming operation. And if you look at this tool, we have some rollers on it. These are highly hardened. They are harder than the workpiece, obviously. And then what we do, we move this knurling tool to right, left, and into the workpiece. And we apply some force while we are moving it onto the surface. And with the help of these rollers on it, we will have such special shapes on it. And the advantage is that once you have such patterns on your surface, then you will be reducing, you will be actually increasing the surface roughness, you will be increasing the friction, so it will be quite easier to handle such kind of pieces, work pieces. If it's a hand tool, for instance, we prefer to have such knurled surfaces on the regions actually where we are handling that tool. And so we can say that this is not a machining operation, it's a forming operation. We don't generate chips in this knurling operation. And then we have, let me focus some other operations we can perform on the same lathe machine. I will start some annotation. Okay, the first one is straight turning, as one of the fundamental operations on the turning machines. For about maybe half of the time on the lathe machines, we perform straight turning operations. And it's very simple. What we do, we actually move our tool a little bit into the workpiece and then move it to the left. With the help of it, our initial diameter is actually reduced. So this is the main function of straight turning. We are decreasing the outer diameter, and with the help of this motion, we can actually improve the surface quality. Since probably these unmachined regions have lower surface quality, probably they are corroded, but once you do machining, you'll have polished, burnished surfaces. Their surface roughness values will be low, and they will be shinier. And obviously, this is depth of cut, as you know. And then we have taper turning. It's very similar to straight turning. The difference is that while moving to left, also we are moving our cutting tool away from the workpiece. So if you have such a movement, then we will not have constant diameter, we will have a conical shape, and that's why it's called as taper turning. Then we have a special process again on the lathe machine. It's called as profiling. The difference is that we can perform any complicated paths with this profiling tool. So it's a very flexible tool. You can obtain any weird shape on this workpiece. If you look at the other ones, they are mostly straight, tapered, but with profiling tool, you can have any various profile on your workpiece. Then we have some other turning operations like external grooving. So this is our external surface, obviously the workpiece, and what we do, our cutting tool moves into the workpiece and then moves to left and then moves out. So with the help of this operation, we can obtain such grooves. And I'm not sure whether you can see in this one, we have a groove here and it's obtained with the help of same approach. And then we have facing. Facing is not a complicated operation. We simply move in the vertical direction like this. And we usually move a little bit above this center line, maybe up to here. You can also technically, it will be enough if you just touch this center line, but in order to make sure that we don't have any chip at the center, at the tip, we prefer to go a little bit further so that you have much better surfaces. For instance, again, this part is actually a facing operation has been performed on this part while we are machining on the lathe. Our tool moved into the center and then came back. Then we have face grooving. It's a bit different. This time we are not machining this side surface. We are actually machining the end face and trying to open a kind of a groove. And let me draw the front view of it. So if it's me draw a kind of a groove. Okay. So that part actually will be grooved with the help of this operation. So you can sit some kind of O-rings inside, some mechanical parts may be directly embedded into this O-shaped or kind of groove. And it's a very special process. If your assembly requires such, let's say, grooves, then you may do this grooving operation on the lathe machine. Now let me move to the other operations here. So we discussed 6 of them and plus knurling, 7 of them. Now we have 5 remaining operations. So you can see that turning operations, the operations we can perform on the lathe machines are quite versatile. We can perform various operations and have difficult products machined on our lathe machine. So this is another one, a bit special, cutting with a form tool. So you see we have a complicated profile. And this is not actually the single process. We can open this profile. We can further use, for instance, if you remember profiling above, we can use profiling to have this pattern. What we will do, we will have a single cutting tool, and then we will move the single cutting tool over the surface in such a way. But the thing is that it will take lots of time. You need to spend more time with profiling to obtain the same shape. But if you are using a form tool, we sometimes name this process as forming also, forming process. We have a special tool. This tool is actually just manufactured to be used for this shape. You cannot use it for other shapes. For different profiles, you need to manufacture a new forming tool. But the advantage is that with a single movement, what you do, you simply move into this workpiece, and obviously your workpiece will take the shape of this tool. So we can say that these processes are almost the same. They can be used for each other instead of each other. But the thing is that forming is faster. It's a bit expensive since you need to spend more money on the cutting tool. But on the other hand, profiling is much more flexible. But the problem is that you need to spend more time to manufacture the same product. So again, it depends on your number of parts to be produced, your cost problems. You need to consider all these issues, cost, time, and manufacturing time, and then decide whether you should go with profiling or forming operation. And we have, as you see, a boring and internal grooving tool. This is another special process, but we will spend more time on boring in the upcoming sections. Right now, we can say that boring operation is actually performed on already opened holes. So in order to start boring, you should have a hole, and the function of boring is to enlarge the size of this hole. So as you see, what happens here is that our tool moves inside, and then with the help of this cutting edge, single point cutting edge again tool, we try to enlarge this inner diameter. And even more, we can do some internal grooving, since if you just open this part, then it will be a kind of a groove inside. But if you have the same diameter throughout this hole, then it's simply boring. Then, by the way, here this thing is important, I didn't mention, but our workpiece is always rotating, and the tools are only moving in some translational directions. As you said, this one is moving, and sometimes it may move also in this Z direction. And in the conventional drilling, by the way, what we do, we put our workpiece on a table, workpiece is stationary, and then our cutting tool drill is rotating, and it goes into the workpiece and remove material. But if you want to perform drilling operation on the lathe machines, you cannot rotate this one. This is not rotating, okay? I'm sorry. This is not rotating. We have workpiece rotating. What we do, we only actually move our drill tool into this workpiece. But since we have the same relative motion, no problem. We can again remove material and have such kind of a hole at this center of our workpiece. And again, we will spend some more time on drilling. We have a special section on drilling. Then now we have two processes remaining, which can also be again performed on the same lathe machine. And this is cutting off. It's very simple, as the name applies. If you have a sharper tool and just simply go into the workpiece, and then this part will be broken, and you will have this part remaining on your machine, and that will obviously fall on the ground, and you need to consider, you need to take it out there and use it. If it's not scrap, you need to use it in your obviously operations. Then we have threading. As the name implies, we are opening threads. So these are threads. This is one lead. The gap actually between the, let's say, teeth. And what we do, we have again a very sharp tool having a very thin edge. We move simply over this surface. But the thing is that we should have a proper relation between the rotational speed and the translational speed of this, or the feed of our cutting tool. If this ratio is not fixed, then you will not have a proper threads on your workpiece. So these are all for the machining processes. We may discuss some other details in the lectures, but these are right now, I can say, on this machining processes. And briefly talking about the quality of turning operations compared to other operations is that if you look at here, the typical dimension tolerances for fine turning operations, we have quite good tolerances, but with a rough turning operation, then obviously, since it's a roughing operation, we need to perform another finishing operation after roughing. If you compare, let's say, with milling, it may be the sewing operation, obviously turning is much better, but on the other hand, it's quite equal to boring, since boring is a much better process in terms of dimensional accuracy compared to turning. But the problem is that in order to do boring, you need to have a hole. And let me stop here for now.